All right, section 4, trig functions. A lot of what we're going to be doing is going to be new this 9 weeks. This first section, there's nothing completely horrible. A lot of little things that we need to know to be successful through all of this. All right, as we're watching this, when a new slide comes up, pause it, copy down the notes, listen to it. When I'm done and I move to the next slide, maybe rewind it a little bit. Do what you got to do to keep notes and get all this down so you can understand the material. I will be teaching this at a pace much faster than we normally do because I'm in my room alone doing this instead of having people ask me questions. So rewind it, listen to it again. At some point you can send me messages through WebAssign or basic email if you have any questions. All right, so trig functions are angles. Down here at the bottom I have 2 angles drawn. I have a positive and a negative angle. All right, our initial side is where the angle starts. For both of these, I drew it on the x-axis. It doesn't have to be this way, but most of the time we talk about angles, we're going to be working with them starting on the x-axis. Our terminal side is where the angle ends. There will always be an arrow from the initial side to the terminal side drawing the angle. All right. Our vertex is the point where they intersect. And I've drawn both of these angles in standard position where the vertex is on the origin and the initial side is a positive x-axis. All right, that's going to be most of our angles that look like these bottom 2. All right, so I've drawn angle theta. Circle to the line in the middle is an angle theta. That's my variable. All right, you're going to see thetas a lot more for angles where we use x's and y's for just numbers. All right, so an angle that rotates up, like this first one, is going to be a positive angle. This angle that rotates down is going to be a negative angle. Starting at the initial side, going to the terminal side with the arrow in between, positive angles go up, negative angles go down. All right. If you did a little bit of trig last year, you're going to be a little bit ahead, but if you didn't, it's not a big deal. Up to, for most of us, probably 98% of the angles we've dealt with before today are going to be angles written in degrees. We know that one full rotation is 360 degrees. All right, we have a new measurement we're going to call radians. Degrees and radians both measure angles. It's just like the same idea as inches and centimeter measure distance. Degrees and radians measure angles. All right, so there's going to be some basic reference angles that we're going to use a lot of. So we're going to say that we know, what we just wrote down, 360 degrees is the distance 2 pi. All right, these reference angles are going to help us make life easier later. So I'm also going to say that 180 degrees, which is half of 360, is going to have the measure of pi because it's half of 2 pi, which is half of 360. All right, going down smaller, 90 degrees is going to be half of 180. We're going to call this pi over 2, which is a half of pi, but we're going to call it pi over 2. 45 degrees is going to be half of that. Half of pi over 2 is pi over 4. So 360 is 2 pi. 360 degrees is the measurement of 2 pi radians. 180 degrees is going to be 1 pi radians, or just pi. 90 degrees is half a pi, which is pi over 2. 45 is pi over 4. All right, we also have 60 degrees and 30 degrees. All right. 60 degrees we can say is a third of 180, so 60 degrees is going to be pi over 3. And 30 degrees is half of 60, so half of pi over 3 is pi over 6. These reference angles are the ones that we need to know. We're not going to memorize them yet, but as we do these over and over again, different problems, we're going to understand what they are. All right? We're going to use them today a little bit. We're going to use them the rest of the 9 weeks. So make sure that you at least recognize these and we'll get into them further. All right, our next idea. I'm going to give you these angles A through G, all in radians. And what you're going to have to be able to do is tell me if my initial side for all of these is on the positive x-axis in standard position, where are each of these angles terminal side? All right, so going through this, we have our quadrants. Quadrant 1, 2, 3, and quadrant 4. All right, so all these answers are going to be one of these 4 numbers. All right, if you did the unit circle last year, this will make a little more sense. If not, we're just gonna go back to what we just did on the last slide and look at these ideas, okay? So I'm gonna start over here on the right side. The angle over here on the right side that has this initial side here that doesn't rotate anywhere is gonna be 0 radians. Okay, I didn't go anywhere, I'm just over here on the positive x-axis without rotating. If I take the angle in radians that rotates all the way around, this same position is going to be the angle 2 pi. Starting on my initial side, and if I rotate halfway around, which is 180, which is my pi. Rotating to the top is halfway to pi over 2. And the last one we're going to have to think a little bit about is if I rotate here to the bottom. The way to think of this one, if I rotate to the top, that's 1 pi over 2. If I rotate to the left, that's going to be 2 pi over 2, and if I rotate it again, I get 3 pi over 2. All right, this is going to be the setup. What this tells us is over here in the first quadrant are all my angles between 0 and pi over 2. Between 0 pi's and a half a pi. Over here in the second quadrant is going to be between pi over 2 and pi. And between a half a pi and 1 full pi. And you'll see this in a second. Keep going. Pi to 3 pi over 2. Between 1 and 1.5 pi's. And 3 pi over 2 and 2 pi. Between 1.5 and 2 pi's. All right, so what we're going to do is we're going to take these angles. We're going to get a general idea where they are and figure out what quadrant they're in. We're not going to do a lot of math. We're just going to do enough math. All right, so we're going to start with 5 pi over 6. When I see 5 pi over 6, all right, I'm going to look at this fraction. 5 over 6, I don't know the exact decimal. It's not that big of a deal, but that's almost 1. 5 over 6 is almost 1, so what I'm going to do is I'm going to rotate, let's say to here, which is almost to 1 pi, because 5 over 6 is almost 1. So if I rotate almost a little bit short of 1 pi, I'm going to be over here in the second quadrant. We're trying to figure out how much pi we have. I have 5/6 of a pi, which is almost a full pi. So I'm over there in the second quadrant. All right, looking at the next one, 17 pi over 9. If I do that math, 17 over 9, that's almost 2. So if I rotate almost 2 pi's, I'm almost all the way around, but I'm not quite there. I'm 1/9 short of all the way around. And this would be 1/9 of a pi, because that would give me all the way around. Puts me in the fourth quadrant. We're just getting a general idea of where the fractions are. All right, 4 pi over 3. All right, I know 4 pi over 3 is going to be 1 1/3 pi's, because that's math I've done multiple times. So if I rotate 1 1/3 pi, I'm going to go, okay, there's 1 pi, which is, if I go do a little bit more math, 1.33 pi, repeating. That's past 1 pi, not quite to 1.5 pi, but closer. So I'm going to go to here and say that angle is my 1 1/3 pi or my 1.33 pi. In between 1 pi and 1.5 pi's is about there, which is the third quadrant. We're just using these numbers to figure out where it belongs. All right, try the next one. Like I said, as we go through these, pause them every once in a while. Don't let me keep teaching, don't just copy. All right, if you pause a little bit, look in here. Negative pi over 4, hey, that's pi over 4 we've already talked about. Pi over 4 is a 45-degree angle, and I'm going to rotate down because it's negative. So negative pi over 4 is right here, which is in the fourth quadrant. I know that one a little bit easier because of the pi over 4 aspect of it. I know that's a 45-degree angle, which is rotated down into the fourth quadrant. All right, negative 20 pi over 11. This, negative 24 over 11, negative 22 over 11 is negative 2. So I'm going to be a little bit less than that, at probably negative 1 point, a big number. All right, closer to 2 than it is anywhere else. So if I rotate down almost 2 pi, close to 2 pi, not as close to 1.5 pi, I'm going to be here in the first quadrant. As we go through these, if you have questions, send me messages. Do something, let me know what's going on. Come see me in the morning. All right, the next one. 13 pi over 6. 13 over 6 is 2 point a little bit, a little more than 2. So if I rotate a little more than 2, I'm in the first quadrant. And this is the logic. Just look at the number and try to figure it out. Don't get sloppy, but try to follow it. All right, the last one. 22 pi over 7. 22 over 7 is 3 point a little pi's. All right, so if I rotate, let me get bigger so you can see it. 1 pi, 2 pi, 3 pi, and a little bit more, I'm in the third quadrant. 22 over 7 is 3 point just a little bit, not quite 3.5, but closer to 3 than it is 3.5. So I'm going to be down there at the bottom. Or I mean, it's the bottom third quadrant. All right, next part, coterminal angles. Coterminal angles are two angles that start at the same initial side and end at the same terminal side. So angle A that rotates up stops at that terminal side, and angle B that rotates down also does. So these are coterminal angles. They have the same initial and terminal side. So what I'm going to do is I'm going to draw 3 more. I can also draw that angle, angle C. Angle C rotates all the way around and keeps going and ends up in that second quadrant. So angle C would also be a coterminal angle. If I wanted to, I could rotate up all the way around and stop here. And this angle, angle D, would also be a coterminal angle. We can play that game for days, because if I wanted to, I could start here, rotate around a whole bunch of times. I don't even know how many times, and stop here, and angle E would also be coterminal. As long as you have the same initial side and the same terminal side, the angles are going to be coterminal. So what I'm going to ask you to do now is we're going to find one positive and one negative coterminal angle given an angle. All right, so I'm going to start at a 45-degree angle. So I'm going to draw a picture of this 45-degree angle. And what I want to know is rotating up and rotating down, how can I get to that same place? So if I rotate down, it's going to be this angle. All right, so I need to think, if I rotate down, my angle is going to be negative. I don't rotate all the way to 360. I'm going to stop 45 degrees short of 360 because I didn't make it all the way around, which tells me that's a 315-degree angle. Because I rotated all the way around except that 45 degrees, which is negative 315. Now for my positive angle, I can start here, rotate all the way around, and keep going another 45 degrees. All right, so my all the way around is 360, and if I keep going 45 degrees, I'm going to get 405 degrees. All right, now looking at that, from 45 to these two angles, what I'm going to do to find a positive and a negative is I'm going to take my theta, and I'm going to add and subtract one rotation. Because 45 minus 360 is 315, 45 plus 360 is 405. All right, so try number 2, 260 degrees. I'm gonna add and subtract 360 degrees, one rotation, and I get 620 and negative 100 degrees. All right, now looking at the picture of this one, I like doing the pictures because we're gonna do this a bunch. All right, if I rotate 270 degrees, all right, my first thought is, well, 270 is all the way to the bottom. This is 270 degrees if I rotate to the bottom. So if I rotate 10 degrees short of the bottom, that's 260 degrees. 10 degrees short. So that tells me if I rotate down 90 degrees and another 10, that gives me my negative 100. All right, so just understanding where it is will help also. All right, so for number 3, I'm going to add and subtract one rotation, which is 2 pi. Can't add those together and get a good looking answer, so I'm going to get common denominators. Put a 6 on the top and the bottom. We get 12 pi over 6, and subtract those. Get 17 pi over 6 and negative 7 pi over 6. All right, so we got to get common denominators and add one rotation, 2 pi, or 360 degrees. All right, so do number 4 then. My version of 2 pi is going to be 10 pi over 5, which is 8 pi over 5 and negative 12 pi over 5. All right, so just add and subtract one full rotation. All right, conversions. Next part. Given an angle in degrees or radians, whatever one it is, we need to be able to convert back and forth between the two. All right, what we are going to do for our conversion is we're going to multiply by 1. The one that we're going to multiply by is a half a rotation divided by a half a rotation. What I mean is either pi radians over 180 degrees or 180 degrees over pi radians. Half a rotation over half a rotation, which is the same on the top and the bottom, which equals 1. What you want to end up with needs to go into the numerator. Degrees to radians, I'm going to put pi radians, half a rotation. And I want to get rid of degrees, so I'm going to put it over 180 degrees. To get rid of radians the second way, I'm going to do 180 degrees over pi radians so I can get rid of the radians. All right, so for number 5, I'm going to multiply. I want to get rid of degrees, so I'm going to put 180 degrees on the denominator, pi radians in my numerator. So I have 125 degrees times pi radians over 180 degrees. I want to get rid of degrees, so I put it in the denominator. All right, so now my math to do this. I'm not going to multiply across the top and the bottom because that's going to look ugly. I'm going to simplify. The first thing that I see that cancels is I have a degrees in my numerator and my denominator, so they're going to cancel each other out. My next step to make it look prettier is I'm going to put this over 1 and realize, wait a minute, I need to look at these two numbers and cross cancel. All right, I see that 125 and 180 is divisible by 5, so I'm going to take a 5 out. All right, doing my elementary school division, 5 goes into 12 twice. Multiply and get 10 and subtract, I get 25, 5, 25, I get my remainder of 0, so I'm good. So when I take the 5 out of the top, I get 25. If I take a 5 out of 180, 315, subtract 306, 30. I get a 36, and I just did elementary division. If you have, you can do it in your head, great, but this math we got to be able to do. So now I multiply across the top and the bottom, 25 pi over 36 radians. I want to get rid of degrees, so I put it in my denominator, 180 degrees, and I left pi radians on the top because that's what I want to end up with. I cross cancel. What makes this one harder is bigger numbers, but you should know the idea. And then multiply across the top and the bottom. So do the same thing for number 6. I want to get rid of degrees. 180 degrees over pi radians, or under pi radians. I'm going to cancel. The first thing I'm going to cancel is the degrees. And the next thing I'm going to do is I'm going to take a 10 out of both of these, which makes my 0 disappear. 54 and 18, I see 9 goes in, which is a 6 and a 2. 6 over 2 is a 3 and a 1. So my answer is 3 pi radians. All right, to make sure we're good, if I graph 3 pi radians, what I'm going to do is I'm going to graph 1 pi, 2 pi, 3 pi. All right, so I'm over on the left side. Now when I do my radian, or my degrees, 540 degrees is 360 degrees plus 180 degrees. So I'm going to rotate all the way around an additional 180 degrees, and I end up in the same place. So I know I have my math right. Graphing the angles. 125 is a tougher one, but 540, if we recognize it as 360 and 180, we can see that it works. All right, let's go the other direction. Pi over 2 radians. Negative pi over 2 radians. I want to get rid of radians. I put pi radians under 180 degrees. Because I want to get rid of radians, I want to keep the degrees. I'm going to cancel. Pi radians cancel. 2 goes in 90 times. So I get negative 90 degrees. After we do this one, I hope you realize that we should have known that one without doing the conversion, because going back to our second slide, we said that 90 degrees is pi over 2. So if I put a negative in front of both of them, negative pi over 2 is going to give me negative 90 degrees. All right? The more we do these, the better we're going to be at them. It's going to work out a little bit easier. All right, 5 pi over 6 radians. 180 degrees over pi rads. Cancel pi rads. 6 goes into 180 30 times. 5 times 30 degrees is 150 degrees. That's one, because it's a pi over 6, we're going to get into a little bit better later. But doing the math, it works. All right, the last one, we're going to get a calculator out for this one. Depending on what the computer wants or what I ask for. If the computer asks for decimals, you need to frame the system, write it as a decimal, and round it to whatever they want. I always want 3 places, round to whatever WebAssign wants. So same idea, 180 degrees over pi rads. Cancel, the only thing that cancels is my pi radians. And I'm going to get 540 degrees over pi. Not a pretty answer, but it's an answer. If WebAssign wants a decimal, all we're going to do is we're going to go to the calculator, which I will do also. Type 540 divided by pi and get 171.887 degrees. Nothing different, just didn't come out pretty. If they don't want decimals and don't say anything about decimals, give the fraction, but if they tell you how many places, round it accordingly and give the decimal. All right, next part. Not every angle is a perfect degree. Just like latitude and longitude lines, if you took your maps and everything, not every town, every place falls directly on a perfect latitude or longitude line. So we have minutes and seconds. One line is minutes, two is seconds. All right, so we're gonna say that in every degree, there are 60 minutes. Each degree can be broken up into 60 minutes. Each minute can also be broken up into seconds, and it can be broken up into 60 seconds. So if there's 60 seconds in 1 minute, and there's 60 minutes in 1 degree, that means there are 3,600 seconds in every degree. And that's going to help us find what we need. All right, so now 60 minutes in a degree is 60 seconds in a minute, which gives us 1 degree is 3,600 seconds. So what we're going to do to convert this to a decimal, again, 3 decimal places for me, answer whatever the website wants. I'm going to take 27 and add 10 minutes and convert it to a degree. So I'm going to change that to 10 over 60. Because I have 10 minutes out of 60, which make it a degree. And then I also want to add 45 minutes or seconds out of 3,600. Because there's 45 seconds in this angle, and there's 45 seconds is part of 1 degree, so I do 45 over 3,600. I would go to the calculator, type this in, don't do a pretty fraction, just type it in as it is, and this is going to be 27.179 degrees. So you're going to do your degree plus your minutes over 60 plus your seconds over 3,600. All right, try number 12. Pause the video, get an answer. I'm going to keep going. All right, the idea for number 12. Negative 139 degrees, 50 minutes, 17 seconds. So what's going to happen here is I'm going to rotate down 139 degrees. All right, so it puts me here. What I want to do next is I want to rotate 50 minutes. And then lastly, I want to rotate 17 seconds, which is just a little bit. Right here. It's not exact, but close enough. So that tells me my angle should be here. And what that also tells me, this angle rotated down 139 and a little bit more. So my angle in a decimal should be 139 point something. If you got 138.7, what you did, all you had that was negative was the 139. And then you started doing positive angles for the rest. So what we should do is I want to make negative the whole angle. If you don't have those parentheses, you rotate it down for 139, and then you rotate it up for the rest of it. So if I rotate down on all of it, I'm going to get 139.838 degrees. The idea for this one, the first one we just added them all together because everything is positive. We need to realize that this whole angle for this one is negative. So I need to either subtract each piece, negative 139 minus 50 over 60 minus 17 over 3,600, or figure out what the angle is itself and then make it negative. All right, last idea. We got 6 problems. We're going to graph each of these in standard position. All right. I'm not going to measure, but you need to be close. You need to be in the same general area. So what I'm going to ask you to do is draw a 30-degree angle. And how we would do this, first thing we're going to recognize is this 30-degree angle needs to be in the first quadrant because it's between 0 and 90 degrees. All right. 30 degrees is 1/3 of my 90. If this is 90 and I want 30, that's 1/3 of what I have. So what I'm going to do, the best I can, I'm going to either mentally or physically draw the angle and break it up into 1, 2, and 3 equal pieces. And then since I want 1/3 of it, I'm going to draw this angle, with my arrow, telling me which way I rotated, saying that this is a 30-degree angle. I don't want to go halfway, because halfway would be a 45-degree angle, so I want to stop short of halfway and do about a third of what the angle is. And that's our idea. We've done it 2 or 3 times in different places. All right, so graph negative 250. All right, for negative 250, I'm going to rotate down. And when I see that, if I rotate down to the top, that's negative 270. All right, so what I'm going to do is I'm going to draw this line here where this little angle is a 20-degree angle. So that means if I stop short of 270 by 20 degrees, that angle is negative 250. Another way is I can think of 250 as 180 and 70, where I rotate down 180 degrees, and then I rotate another approximately 70 degrees. Either way gets us there. All right, 750 degrees, 750 degrees. This one's larger than my 360, so if I look at this, I can say 750 is 720 plus 30, all right, where 720 is 360 plus 360. So what I'm going to do here is I'm going to rotate around twice, which are my 2 360s. And then I'm going to rotate another 30 degrees, which is my 750, and it's the same 30 degrees that I drew up here. So I went about a third of the way. I didn't go halfway, I went about a third of the way. All right, negative 520, give it a try. So if I go down 360 and another 90, that's 450 degrees, which leaves another 70 degrees that I need to go, which is going to be 20 degrees short of another 90 degrees, which puts me about here. And like I said, it doesn't have to be exact, but you should be close to where you need to be. So you could have made this angle a 70-degree angle, or you could have made this one short by 20 to get to where you need to be. All right, make sure, and I didn't do it on that one right away, but put those arrows on the end. All right, last two. 5 pi over 4. All right, looking at this one, I know I can take 5 pi over 4 apart into 4 pi over 4 plus 1 pi over 4. All right, that's because that gives me good, because that gives me one good angle that I know of 1 pi. So that takes me halfway around. 2 ways to do the rest of this. We also know that pi over 4 is that 45-degree angle, so I'm going to go an additional pi over 4, or 45-degree angle, giving me my 5 pi over 4. All right, so if you see that that works, what we can also do, let me erase this and start over. We know that 4 pi over 4 is halfway, so that's the same. We're good here. All right, the bottom half of this has a measurement of pi. All right, so the bottom half has a measurement of pi. What I want to do is I want to go 1/4 of this pi. So I can think of if the whole thing's pi, and I separate this accordingly, I can cut that pi into 4 equal places. All right, so I cut it into 4 equals. So if it's 4 equals and I want to go 1/4, it tells me I want to stop at this first line, making this 5 pi over 4. If I wanted to go to an additional 3/4 pi, I would have to rotate over here to the third line. Right, but pi over 4 we know is a 45-degree angle. And this idea of cutting up is going to help us on this last one. Negative 2 pi over 3. I know I'm going to rotate down, and I'm not going to rotate down halfway around because I only want 2/3 of the pi. So I'm going to look at this as 1 full pi. I want to rotate 2/3 of it, so I'm going to separate this into 1, 2, 3 equal places. Cut into 3 equal sizes of pi. Since I want 2/3 of it, I'm going to take this and I'm going to rotate down to the first to the second 2/3 of the way and make this negative 2 pi over 3. All right, so that's today's lesson. If you have questions and need help, come talk to me in the morning. If you need other help, send me a message through WebAssign or send me an email. I'll do my best to respond. But if you need any help, talk to somebody, talk to me. If not, I will see you in class on the next day. Have a great one.